I'm Dr. Anthony Deese. Welcome to our modules on servlets and microservices for AWS Elastic Beanstalk. I provide lectures on topics related to electrical and computer engineering, as well as computer science, with emphasis on the Internet of Things, distributed computation, cloud services, and machine learning. Now, these modules emphasize learning by doing or hands-on learning over theory. Focus is placed on providing you with thoroughly explained code examples that demonstrate how to achieve certain objectives, like creating a microservice. Our hope is that you can use these more basic examples as a framework or jumping off point for the development of more advanced implementations. These modules are designed to be short and concise, such that you can start creating your own implementations for your own projects as quickly as possible. If you're interested in theory, I provide additional resources for you to examine. The objective of these modules is to provide you a hands-on introduction to developing servlets and microservices on your Windows machine for deployment to Amazon Web Services, relying predominantly on the Elastic Beanstalk service. The videos are divided into subsections indicated by the labels at the bottom of the screen. This allows you to manually navigate each lecture. We provide you with editable text copies of all the source code that we use. These external resources are labeled in my notes as resource and then some numbers, so let's say 10.10, and you can download, save, and use these resources however you see fit. At the beginning of each module, I'm going to outline the type of machine and software that you'll need. Overall, you will need a reasonably fast Windows PC with Node.JS installed, as well as a good code editor like Notepad++. That's my preference, although you could use Eclipse or something like that. You will also need to have Express.JS, Apache Tomcat, and Spring Boot on your PC, although we're going to talk about those specifically as part of later modules. Now, also at the beginning of each module, I'm going to outline the prerequisite knowledge you'll need to maximize understanding. These modules overall require some basic experience using Node.js, as well as, you'll have to know how to code in at least Java and JavaScript, a little bit of HTML for these modules. I think you'll still get a good experience from the modules, even if your programming is a little bit weak, because it provides you an opportunity to learn more about that type of coding. Now, the course is divided into several modules. I'm going to quickly give an overview. The first module is a background module. We're going to talk about, and this is not all-inclusive, clients and servers, APIs, servlets, and microservices. Then the rest of the modules are pretty much 5 examples. So the next example is developing an image server for Windows 10 via Express.js. Then after that, we have an example which asks us to configure and test our machine, our Windows 10 machine, for Apache Tomcat. The next example asks us to develop a Java servlet for Windows 10. This is going to be deployed locally only via Apache Tomcat. Then the fourth example, we're going to take that same servlet and deploy it using AWS Elastic Beanstalk, so it will be available on the web to anyone who's interested in using it. And then the last example, which is a really interesting one, and really the whole set of modules builds up to this, is one that asks us to deploy one or more microservices using the Spring framework, again for AWS Elastic Beanstalk. So that's the end of our introduction. Next, we're going to go ahead and jump into our background module. Welcome to our background module for clients, servers, and gateways. This video is divided into subsections indicated by the labels in the bottom right-hand part of the screen. These labels will allow you to manually navigate the lecture. Any external resources are highlighted by a resource number like RES001, and you'll find the corresponding resource in your accompanying course files. You may download and save these resources for your use later. Many of them are sample pieces of code. The objective of this module is to provide you some supplemental background as required to understand the examples we'll cover later on. It's the background section of these modules. There's no machine requirements because this is a background section, not an example, and no prerequisite knowledge. We'll be discussing the following topics: abstraction and protocols, protocol layering, application programming interfaces, software development kits, software frameworks, Java servlets, API gateways, Node.JS and Express.JS, Apache Tomcat. However, the first topic we will discuss is the client-server model. Let's go ahead and jump into that. client-server model describes a distributed application structure where certain tasks are performed or resources are hosted by machines referred to as servers. Other machines, referred to as clients, may then request that the aforementioned task be completed with input that they potentially supply. They may also request access to read from or write to these resources. Today, the internet generally facilitates communication between clients and servers, although local Ethernet or other hardwire connections may be used. We will focus primarily on internet-based applications. Typically, clients don't share resources and servers don't make requests. Servers wait for requests and then perform them as they come in. Clients make requests as required for their applications or whatever objectives they are trying to achieve. However, a machine can act as both a client and a server. So let's take one example. A local server hosting a web page that in turn requests image files from another cloud-based server. Email generally employs a client-server model. The application that we have on our phone is merely a client, storing minimal information locally. The contents of our inbox and those individual emails within it are provided to the client upon request from an external server like the Gmail email server. So let's talk about some relevant terms. Web server and client, I think we've already covered this. We know what the server is, we know what the client is. HTML and HTTP, these are important terms to understand. HTML is the hypertext markup language. It's a common language used for communication between a client and server. The Hypertext Transfer Protocol, HTTP, is the communication protocol used for this interaction. Some important parts of the HTTP request are the method, which describes the action to be performed, get, post, put, etc. We have the URL, the Universal Resource Locator, which is used to access the page or direct the request to the appropriate server. And then we have the form parameters, which represent the arguments or the inputs to the function. The server will reply or can reply with an HTTP response, which consists of a status code. Any of you who have had a web page not load are familiar with these, right? This status code indicates whether the request was successful. That's usually code 200, not found, the famous code 404, or access forbidden, code 403. There's other status codes that exist. There's a whole bunch that exist for different situations. We're not going to go through and list every single one. We also have the content type. So this is the type of response known as the MIME type. And then the content, that's the actual data to be returned. We talked about the URL, the Universal Resource Locator, and the Universal Resource Locator, which normally starts with HTTP or HTTPS, secure or non-secure, may be broken down into the following pieces. So the HTTP : / tells us that the HTTP protocol will be used. Then we have the address, as well as the port, as well as the resource to be requested. And so when we get into some of the examples, we'll dive a little bit more into HTTP. I have some more information written down in front of me, but I feel like perhaps it may be better to be discussed later. Now, this is a relatively short course focused on hands-on learning. And this is an introduction to servers. The modules are not going to discuss the details of developing Linux-based servers or large server systems. This is really just an introduction, as I said before. So let's talk a little bit about abstraction and protocols. One important aspect of the client-server model is abstraction, meaning that the client does not have or need any understanding of how the server operates. It's presented to the client as a black box characterized by the services and resources it can provide, as well as the inputs and outputs that should be associated with those requests. A protocol describes the interface that a server presents, as well as the rules that allow multiple machines to interact, including the syntax, the semantics, synchronization, and possible error handling methods. One well-known example, again, we're talking about HTTP, the Hypertext Transfer Protocol. It dictates the proper way in which a client may communicate with a web page, requesting access to the host server. The client must specify, a little bit of repetition here, the type of request, get versus put. There's others as well. The destination of the request using the URL or IP address, any relevant header fields, and an optional message body. Other protocols may be structured like an object-oriented method, where a client makes a function call with associated input variables and waits for a response containing results. We will discuss protocols more as we dive into our examples. The most effective protocols are standardized and published by organizations like the International Organization for Standardization, ISO, or the Institute of Electrical and Electronic Engineers, the IEEE. Next, let's talk about protocol layering. Today, protocols are often layered to create what's called a stack. This allows a more complex protocol to be divided into smaller pieces, each of which with its own meaning and role. For example, the Internet Protocol Suite, also referred to as TCP/IP, is composed of two others, including the Transmission Control Protocol, TCP, and the Internet Protocol, IP. We'll talk a little bit more about that later. The next topic I want to discuss is the Application Programming Interface, or API. Now, I know for many of you that have the proper background for this course, you are more than familiar with APIs, so forgive me as I spend a second talking about it here. In some cases, the communication between a server and a client may be defined by a remote or web type Application Programming Interface, API, and its associated libraries. This allows a developer to communicate with an external service like Amazon Web Services using methods within a given programming language. This provides an additional layer of abstraction where the developer does not necessarily need to understand that they are communicating with an external service at all. From their point of view, they're simply calling a method. APIs may fill a variety of roles. Another way to describe an API is a set of subroutine definitions, communication protocols, and tools for building software. In general terms, it's a set of clearly defined methods for communication between various components. The most basic description of an API, and I know I've given several descriptions here, but there are several different ways to describe this, is an interface. It's an interface that defines the interactions between different software objects as well as software-hardware intermediaries. So hopefully you can connect the dots between these different definitions that I'm giving. The API is an interface that allows us as a software developer to communicate with various other resources. It provides that interface that tells us how to retrieve information and how to send information and request that different actions be taken. So it presents to the developer a set of request methods to be used, as well as how the request should be made. What are the appropriate data types, conventions, etc. APIs simplify the development process, again using abstraction. It hides the details of more complex operations, exposing only the information needed to facilitate its use. For example, the AWS DynamoDB API, this is for Amazon Web Services, provides developers functions like getItem, which allows us or them to retrieve an externally hosted database object with minimal effort. One alternative to this would be to use a REST type architecture, which is going to be a little bit more complicated. It provides, and when I say it, I mean the API, provides a more user-friendly alternative to communicating with AWS, well, I'm repeating here, via REST or HTTP protocol commands. The party that develops an API should provide documentation describing how its methods may be used. Is it synchronous or asynchronous? What methods exist? What inputs does each method require? Are some optional or mandatory, required? How are outputs returned? Are they returned directly, or does it employ a callback function? Now, related to the topic of APIs is the SDK, the Software Development Kit. Again, I know another topic that many of you are going to be very familiar with. APIs are often contained within a Software Development Kit, SDK. The simplest description of an SDK is a collection of development tools in a single package. One well-known example is the Java Development Kit, JDK, which contains many programming tools, including a compiler, which is referred to as Javac, or that's the file name for it, the documentation, Java doc, and the loader for Java applications, simply called Java. Now, there's many more components in the JDK. We're not going to talk about all of them. Another example of an SDK that we are going to talk about is the AWS SDK for Android, which contains the aforementioned DynamoDB API. So an SDK, a software development kit, may contain different APIs, and that's another one of the tools that we're going to use for development. Software framework, another term I want to discuss briefly. A software framework, or simply a framework, may be thought of as the skeleton of an application, or a completed application where the functionality is generic and not completely defined. If a developer's goal adheres to the structure defined by the framework, then we or they may build their application using that framework as a starting point. This reduces development time and complexity. In many cases, a framework is simply composed of multiple libraries that provide the types of functionality that we need as a developer. One key characteristic of a framework is its ability to configure certain parts and expand upon others. So you think about the framework as a scaffold, where you can put pieces into it in order to build up the interior of the scaffold, but you can also build on top of it to make the scaffold taller than it was, or wider, and insert new functionalities that weren't necessarily thought of as part of the original framework. So one example, Android Studio provides a framework for developing mobile applications for Android OS. It provides developers with objects called views, which may then be configured in an infinite, well, almost infinite number of ways. A framework is the scaffold, I used that term earlier, the scaffold of an application within which developers may configure the functionality and introduce new functionalities to the scaffolding. Okay, a couple other terms, actually there's two more left that we want to talk about. Java Servlet, and all these are going to be called upon later in these modules. Java Servlet. It's a Java software object that extends the capabilities of a server. It's a Java class, which responds to a specific type of network request, most commonly an HTTP request. Check out resource 006 if you want one of the references I use to talk about this. Servlets are commonly used to implement web applications. However, they may be used for other things. Servlets run in a servlet container, which manages the servlet's life cycle, maps a URL to the servlet, and handles access rights. One example of a servlet container is Apache Tomcat, which we are going to use here. A Java server page, or JSP, allows developers to create dynamically generated web pages based on HTML or XML or similar types of languages, except it's coded in Java. API gateways. So what if we want to facilitate communication between two objects that employ different protocols? We can use a gateway for this purpose. It's a computer program which accepts a request from client A via protocol A, translates the information to the form required by the target or desired server B, which employs protocol B, and then relays the reformulated request to this target server B. It will also perform this translation in the reverse direction. Now, some gateways are physical hardware. A router, a Wi-Fi router is technically a gateway. Others are simply a combination of a client and a server together, acting as the server for client A and the client for server B. So it's the sort of intermediary. One especially interesting form of a gateway is the API gateway, one that functions like an API. Here in these modules, we are going to examine the development of a Java API gateway, a specific type of server that acts as an API front end. It receives API requests, enforces throttling and security policies, as well as passes requests and responses to and from the back-end service. So this is going to allow us to create our own API, which is very cool. If you have, let's say, a piece of hardware or software or some sort of database or process or object that you developed, and you want to make it available to other developers or to yourself even in a more abstracted or easier to use way, then an API gateway is going to be one primary and very effective way of doing that. Node.js. Don't think there's too much of a need to talk about this. I think that anybody who has the background for this course would be familiar with it. It's a JavaScript runtime environment. It executes JavaScript code without a web browser. So the traditional way of running JavaScript code is within HTML, and then you would essentially bring the application up in a web browser. But Node.js gives us an alternative. It's a compiler for JavaScript code which employs command line execution, which can be advantageous in for certain applications. You can download and install the newest version of Node.js. It's easiest probably to just Google this, but if you want the link, it's nodejs.org/en for English. Okay, next, let's talk about Express.js. So the first example that we're going to go over employs Express.js. It's a back-end web application framework for Node.js, meaning that we can execute the code that employs Express.js using the compiler provided by Node.js. It provides us the code structure required to quickly and easily build a server, remember that's the topic of these modules, that hosts pictures, text, web applications, and it can even host custom APIs. Express.js may be downloaded. Again, it's probably easiest just to Google this, but the URL is express, normal spelling, js.com, only one dot before the com. So let's talk a little bit about how Express.js works, and a lot of these concepts are going to transfer over to servers in general. Routing and route parameters for Express.js. Now, a lot of this will apply for other software, other server-related software, but we're talking specifically about Express.js right here. Okay, routing defines how an application, and this could be potentially within a server, responds to a client's request, composed of a path, which is defined by a uniform resource identifier or URI, a request method, which could be get, post, put. We've talked about those before. Check out this resource if you want some more background on this. Again, this is downloadable or available in your downloadable course resources. A route may have multiple handler functions to be executed upon request. Express.js employs a route definition like that shown below, right down here, where my app is the instance of the Express server that we have defined, or the Express object that we have defined. Method X is the HTTP request method in lowercase. Path Y is the path for the target resource on the endpoint or server, and handler Z is the function to be executed for this specific route if it succeeds. Now let's look at an example that simply responds with a string saying success. We employ a get type request aimed at the root path of the server denoted by this right here. So the path that we have defined is simply the root of our endpoint. And that's what the / indicates, simply the root of our endpoint. We will employ an inline callback function with two passed inputs. So you can see here our handler, which I have to go a little bit around, is this entire piece right here. The inline callback function, which is then defined below or within the brackets. Now, this inline callback function only has one line, and it's essentially calling the response object and asking that to allow us to send a response back to the page. Okay, so just to compare these two, we have 1 and we have 2. My app stays the same. We're still using an instance of our Express.js object or server. Our HTTP request method is get in this case. We already talked about our path and we talked about our handler function. So what is happening right here? The response B, which is the response passed by the response passed to the callback function, has
a member function called send, and then we place in send the message that we want to send back. We may also add some route parameters. For example, let's pass a message to the endpoint, which is then returned to the client as its response. So what we're doing here is, as opposed to sending a generic response of success, we have the client, which will provide a message. It will send that to the server, and the server will return that same message back to the client if the request is successful. Again, not very useful, but it allows us to show how we can extract that attribute from the, how we can extract that route parameter. So let's take a look at what we have. Same instance of my app, which is the Express.JS server. Same HTTP request method, get. Now, and also a similarly formatted inline call back function. The difference is this piece right here, our path, is no longer simply just the /. Now let's take a look at what this really says. I'm just rewriting this. Sorry, I ran out of space. So imagine that message to R is the same as message to return. Now, what this is doing is it's allowing us to pass a variable to our callback function as part of the URL which is used. In that URL, we are going to have two additional pieces appended onto the end of it. One is going to be the key for our parameter, and the other is going to be the value of our parameter. And you can see here the use of this colon is very intentional to indicate that that is the value. Now, what is happening inside of the body of our inline callback function? We're still calling upon our response. We're still going to send, but now what are we doing right here? So we are taking our request. We are then accessing the parameters of that request, and we are accessing the parameter with the key of message key, which we define right here. So whatever this value is, or whatever this key is, needs to be called right there. And the expectation is that we are accessing the parameter with the key of message key from request A, and that will spit back whatever the value is. So I know I've written a lot on the screen. It's probably made it a little bit hard to see, but what does this code do right here? Exactly what we said above. It allows the client to send a message along with its HTTP request. And then our server is able to parse that, pull out that message, and return it. Well, it could do something else with it. Potentially, it could return it back to the user. Now, we're going to get more into this when we talk about our example. Let's talk a little bit about response methods. So, again, check out this resource if you want more background, available resource 005. So the viable response methods are shown below in this table. So far, we've been using this one, which is send a response of various types. We have lots of other different options. We can download a file from the response. We can end the response. We can send the response as a JSON object. We can send this as a specialized type of JSON object. Redirect a request, render a view template, send a file, and send the status. Now,
There's one last topic I want to discuss here in the background section for these modules, and that's Apache Tomcat. Apache Tomcat is an open source implementation of the Java servlet. It provides us a Java-based environment to develop web application servers. We're going to use Apache Tomcat pretty heavily in the second example that we take a look at here. Anyway, that's the end of this module. The next topic that we're going to discuss is actually an example, which is asking us to develop a Windows-based server via Express.js.